And good afternoon. This is Scott WA9WFA with a mechanical review of the Ted Crosby W6TC's HBR-13 receiver. This receiver article came out in QST in 1965, and it was 13 tubes. This one's 12 because I have diodes for rectifiers in the power supply. But from the front panel, the highlight is the Eddystone 898 vernier dial, and it is a dream. It's just so smooth to turn. It's probably the best vernier dial ever made, in my opinion, okay? But just very smooth and very articulate, you know, with the small graduated dial in the center here, and then the large slide rule dial that goes end to end. There's no markings on here because I have not finished aligning and calibrating it yet. So I just, the start of the band, 40 meter band, is actually up around 100 right now, but that's just for now. So have a control for peaking the RF input, the controls for muting and standby. Then there's controls for the RF gain, there's mixer gain, there's IF amplifier gain, so lots of gain. The controls for BFO on and off, the volume control, the BFO adjustment, and some speaker selection switches. And I have a beautiful aluminum front panel that was made for me that I have not attached yet. I built this plexiglass panel because there was so much going on mechanically. I wanted to be able to see the holes, see what I was doing as I was going across. And I've had several friends say, gosh, it looks really nice just the way it is because you can see everything. And so I may just leave it like this. But this is the front panel. And I'm just going to turn it on the side here. And so it has a sub chassis on the top, and inside this sub chassis contains the RF amplifier, stage, the mixer stage, the first mixer, and the first oscillator stage. And these are all plug-in coils, and that's how Ted Crosby designed it, because he felt it was a lot easier than trying to wire up a 3-gain switch, okay? 3 wafers to cover, switching all this stuff, and I agree. It's definitely a lot easier. But this circuitry sits on a separate aluminum chassis that's raised above the panel. No, I'm sorry, raised above the main chassis, okay? This here, just a fabulous 3-gain variable capacitor with bearings, ball bearings on both ends. Wow. And it's just as smooth as it can be. I do need to lubricate it though, because I expect to be able to spin the Eddystone dial and have it travel farther than it is. So I think it just needs a little bit of lubrication. But the RF amplifier stage, this is the first mixer stage, and this is the HF oscillator. Okay, the HF oscillator stage. The first IF, because this is a dual conversion receiver, the first IF is at 1610 kilohertz. And so this is the first IF transformer, IF amplifier, and another IF transformer. These are from a Hallicrafter's SX99 or an SX100. Some generous person sent them to me for use in this receiver project. Then the output of the first IF goes to the mixer. This is the mixer stage, so the second mixer. And here's the crystal oscillator, and it's operating at 1710 kilohertz. And so the output is 100 kilohertz. So that is the second IF frequency, is 100 kilohertz. And we go into two IF transformers back to back, an amplifier stage, another IF transformer, another amplifier stage, another IF transformer, and then onto the product detector. Okay, and the product detector is mixing the 100 kilohertz signal that comes out of this chain with the just slightly less than 100 kilohertz beat frequency oscillator. And that's what this module is here, is the beat frequency oscillator. And it's in its own separate box. Because otherwise, if the BFO was just unshielded, I'd be hearing it all over the place. Okay, and that's why this shielding is in place here too, because I don't want to be hearing the HF oscillator in the RF amplifier, for example. So then this is the audio tube here. As I mentioned, the BFO, the S meter, and the section for AGC. So there's two audio amplifier stages in that single tube, so it has a lot of power. And the transformer. Underneath, you can see one of my greatest challenges is right here, is hogging out this opening, milling out this opening. And I had to learn how to use the Bridgeport milling machine at work. I had never used one before. I am mechanically inept, and so this was a real challenge for me to actually have this thing mechanically look good, okay, and not be a mess and be unstable. So with the Bridgeport, I was able to mill out the front panel and drill the holes. With the same Bridgeport, mill this out and drill all the holes that's needed. So this is underneath that sub chassis that has the RF amplifier, the first mixer, and the coils, and the HF oscillator. And then over here it comes out and heads on down the 1610 kilohertz IF chain, and then into the second mixer, which is mixing it down to 100 kilohertz, so the second IF frequency. And that's what this whole chain is right here, is the 100 kilohertz IF chain. And then at the very end is the product detector. And the product detector is really just another mixer, and it's mixing the 100 kilohertz signal chain with the nearly 100 kilohertz beat frequency oscillator. And that converts it to audio. Okay. And so some potentiometers here for the S meter control, and the audio amplifier and AGC section is down here. I do need to spend some time in here because the AGC is not working right, and I just not debugged it yet, so it just needs a little bit of time. Over here on this side is the power supply, and just using a full wave bridge rectifier and using diodes for that. And that's pretty much it for the bottom. The challenge really mechanically is just getting the openings made, because these are special. I haven't seen these in other projects. Here's the large opening here for the weighted wheel on the Eddystone dial. And I built this larger than Ted Crosby's HBR-13 because this was my first project and I needed more space. Okay, I'm not a master at building things to begin with, and I'm certainly would struggle cramming it all into a small box. So I did spread it out, and I didn't run into any problems spreading it out, meaning sometimes you spread things out too far and you get unintended coupling and other bad things. And as an example, when Ted Crosby was testing this out, testing out an HBR-13 that Alex Stewart built, Alex wasn't able to get the IF amplifiers to oscillate, meaning to go into regeneration. And that was a feature of all the HBRs, that it regenerates. And it was because Ted Crosby thought that it was due to this section here, this RF front end and all, being placed in the middle of the chassis. And he wanted to do that so because the dial would be then right in the middle and look really nice. But they had trouble getting the mixer and the IF amplifiers to oscillate, to go into regeneration. So when I built my version, instead of putting the dial in the middle, I put the dial over on the left, which is typical of Ted Crosby's designs, his HBR-14, 16, 11, and 8. We're all on the left side. He had everything over here, so it wouldn't have any problems going into, well, I shouldn't say have problems, but it went into regeneration without any difficulty. This version, there is no problems getting the RF amp, or getting the amplifier and the mixers to go into regeneration. It's so it has a lot of gain. So mechanically it would have looked pretty in the middle, but electrically I think it works out better over here. I do have some work left to do on this. As you can see, the BFO control is not going to be setting out this far. I've got it on an isolated shaft, and I just simply haven't cut the shaft yet to get the knob back down. And there's one other thing that I need to look at as well. I smell something out of the radio. You know, it's not an overt burn, okay, but when it's running for a while, I can smell something, and I'm not sure what it is. So I recently retired, so I no longer have access to like thermal imaging or anything. So I'll just have to spend a little bit of time to see what's getting warm in here. But anyway, the front panel made from plexiglass, and that was done again for my ease to be able to mechanically place things and see what was going on. Right now I plan on leaving it this way, but I am thinking about making a little cabinet over it. And I don't want a big massive cabinet. I'm thinking just making a small thin aluminum cabinet that just literally just rides right over these rails here and is just tight. But I do need an opening. I need to open the lid because I need to get access to these 3 coils, okay? Because that's how you change the band on the HBR series. So anyway, it took me several years to build this, you know, with a lot of time in between with this sitting on the shelf while I recharge. And I wanted to make this video just to share with friends around the country what it looks like, you know, because I've been talking about it for several years, and I was beginning to wonder if they thought it was just a rumor, okay, that this HBR-13 was just a figment of my imagination. But here's my HBR-13, my very first radio project, and I'm really pleased with how it turned out. I've learned a lot, I tell you, a lot. And I built a smaller radio as a second project that I'm still working on. That one's only 3 tubes, and that one was a challenge, and I'm learning a lot from that, just because it's small, compact, things are crammed in there, and there's not enough system gain. So anyway, between those 2, I'm getting ready to start a 3rd receiver project now, and that one may be the HB67 from the 1965 ARRL handbook. I'm seriously thinking about building that one. So I got one more tube receiver in me yet before I'm thinking about going solid state and building my own solid state receiver. So anyway, this is a mechanical tour of my HBR-13. I have another video up that shows the HBR-13 in operation, again to dispel the rumor and show that it actually works. It actually works well. So I am excited to put this on 20 meters and 80 meters to see what it sounds like up there. especially on 20. That's where the rubber meets the road, because that's where stability is most critical for these radios. So there you have it. So this is my HBR-13, built by Scott WA9WFA. Thanks for watching. Bye.